Okay, we're going to look at the proof that there are infinitely many primes. So we assume something and then contradict it. Assume there are finitely many primes. So that means there is a biggest prime. Let's call it Pn. That's our biggest prime. Okay, so consider capital Pi, capital P, the product of all the primes. So 2 times 3 times 5 times all the way up to Pn minus 1, the one before the biggest prime, and Pn, the biggest prime. So we want to consider this big thing here. Now, so that's a product of all of the primes. How about pi plus 1? Okay, so either pi plus 1 is prime, which is a contradiction because it's clearly bigger than Pn, right? Which we assumed. Assume there are finitely many primes, so we assumed that there's a biggest prime. Or it doesn't have a prime factorization because these are all the prime factors. It's one more than all of these prime numbers times together, and the smallest prime is 2. So if you divide it by any of the primes, you get a remainder of at least 1. So it doesn't have a prime factorization, which is also a contradiction. The fundamental theory of arithmetic. Every number has a prime factorization, a unique one. So there you go. So either which way you look at it, we've got a contradiction. So there must be infinitely many primes.